The suburbs, one of the most dangerous places on the face of the earth.
The exotic landscape and culture of the suburbs
Draws close to 8 million tourists every year, and on average, 16,000 of them won't return home. My name is Jake Drury, and I've served with the U.S. Marine Corps for close to 12 years. Reached the summit of all 7 peaks on the continent when I was only 18, being the youngest to ever do so. And now, I'm here to show you the necessary skills for survival in such a hot. If you want to get lost in such a treacherous terrain in a harsh climate, it's not going to be just you getting lost out in the world. It's going to be some sort of violence, some sort of dangerous fall or injury that you're going to have to fight for your way back. In order to simulate this and make it as close to reality as possible, my crews dropped me off at the peak of a mountain with an elevation of 16,000 feet. I'm going to parachute all the way down. Hope for the best climate I can to get a little bit easier trek back home in this just unforgiving landscape. As you can see, I'm very high up here, just at an unbelievable height. Well, let's get started. Oh, here we go. Oh, wow, that was brutal. Where is it? It's gotta be in here. Oh, there we go. Well, haven't landed a very good climb, just miles and miles of plains you're gonna have to trek across first. This is not where you want to be. It's already starting to get dark, so we're gonna have to find some shelter very quickly. The main killer in this harsh environment is just its weather, as it gets up to very high extremes and very low extremes in the day and night. At night it gets close to -4 degrees, and all you're gonna want to do is find shelter and warmth to survive the night and make it to the next day. We've been walking for close to 8 miles, making good land on the first night, but it is almost nighttime and I'm gonna need to find shelter quick to protect from this just bitter cold environment and the heavy rainfalls at night. I've come across a perfect shelter. An isosceles trapezoid-like shape with channels on each side to funnel the rain away from you, and a wall behind you to protect you from all that water buildup, and even a little wall in front of it to block from any extra rain coming down on top of you, and some nice soft warm earth. Now that we have this perfect trapezoid-like shelter to rest during the night, I'm going to show you all a few tips and tricks on how to point one of these things out. It can be very confusing and one of the most tricky parts of staying alive out here, but it can be the difference between life and death and you making it home.
A trapezoid consists of 2 main parts, the bases and the legs. This is a very common misunderstanding, as the bases aren't just any 2 opposite sides, but they're actually the 2 parallel sides, while the other 2 remaining sides consist of the legs. Getting the properties down for the shape you're studying can be a lifesaver during the lesson. The properties for a normal trapezoid is it has 2 base sides and 2 leg sides and 2 pairs of base angles. For an isosceles trapezoid, everything is the same, except an isosceles trapezoid has 2 pairs of congruent base angles and both diagonals are congruent. Here we have trapezoid JKLM. And let's say angle L equals 85 degrees and line KL is parallel to line JM. Now we're going to find angle K, angle J, and angle M using the properties that we just went over. So to find angle K, since JKLM is an isosceles trapezoid, so angle K and angle L are congruent base angles, which means angle K equals angle L at 85 degrees. To find angle M, because angle L and M are consecutive interior angles formed by line LM intersecting 2 parallel lines, they are supplementary. So angle M equals 180 minus 85, which would be 95 degrees. And to find angle J, because angle J and angle M are a pair of base angles, that means they're congruent. So angle J equals angle M at 95 degrees. And there we have our 4 angles for the trapezoid. So now we have the mid-segment theorem for trapezoids. The mid-segment theorem helps you find the middle of a trapezoid. The mid-segment theorem is 1/2 base plus base. So our formula for this trapezoid, since we have base 1 right here and base 2 right here, it would be 1/2 AB plus DC equals MN. Using the mid-segment theorem of a trapezoid, we're going to find the mid-segment of this trapezoid with a base of 12 inches and 28 inches. So first thing we're going to do is set up our formula. So MN should equal 1/2 of 12 plus 28. So first thing we're going to do is solve the parentheses. So MN equals 1/2 of 40. Easy enough. Then all you do is divide the parentheses by 2. So MN should equal 20 inches. It's a pretty simple process.
So it's the second day in this treacherous climate. I covered a bunch of land today, making great progress. And now it's time to begin our departure. Depending on where you are, what your location is, the best way to get attention from any bypassers is to either make a bonfire, put some greens on it, and make white smoke, or write SOS on a beach to get attention of planes and boats passing by. But in the suburbs, with the skies usually clear, we're going to have to fly a kite. That cause a great distraction in the air, getting attention of many bypassers.
We've been at it for a while. As you can see, the skies are clear. But I mean, getting attention is just going to take a bunch of perseverance and hope that somebody will see you and take you home. It's all about just getting rescued at this point. Just stay near a water source. As you can see, I'm next to a lake and some food. I mean, it's just going to take some time now.
Hey, need a ride? Looks like a chum.
Kites are definitely one of the easier parts of this section. A kite is just a quadrilateral that has two pairs of consecutive congruent sides, and the opposite sides are not congruent. Two things you need to know about a kite is that if a quadrilateral is a kite, then its diagonals will be perpendicular. And if a quadrilateral is a kite, then exactly one pair of opposite angles will always be congruent. Using the properties we just went over, kite DEFG has exactly one pair of congruent opposite angles. But since E and G are not equivalent, that means D and F are the pair of congruent opposite angles. So to find D and F, just set all the angles equal to 360. So D plus F plus 124 plus 80 equals 360, since all quadrilaterals angles equal 360. So now we can substitute D and F for just any variable since they're the exact same thing. So 2x plus 124 plus 80 equals 360. So now we combine our like terms, so you get 2x plus 204 equals 360. Then you just subtract from both sides and you get 2x equals 156 divided by 2, and x equals 78. And there are your two angles, 78 degrees. And finally, to find the side lengths of a kite, since we know that the diagonals are always perpendicular in a kite, we can just use the Pythagorean theorem to find the sides. So 3 squared plus 5 squared equals x. So just square these two numbers and you get 9 plus 25 equals 36. Square root of 36 equals 6. So this side length is 6 and this side length is 6, since both of these sides have the same measurements. So now for the top half of the triangle. So 3 squared plus 3 squared equals x. Then you get 9 plus 9 equals x, and 18 really, and the square root of 18. So this half is square root of 18 and the square root of 18.